Hello, everybody. Welcome back. So now we're going to begin a whole unit on just some algebra review to kind of buffer up our algebra skills before heading into next year's math, okay? So this should be a review for everybody. This should not be anything unfamiliar for you, okay? So we're going to talk about just different functions and the parent functions and then the transformations of those functions. So we're going to begin with just the line y equals x. The line y equals x just means whatever x equals, y equals. And so if you have a table of values, x and y, if x is -2, y is -2. Whatever, if x is -1, y is -1. If x is 0, y is 0. So whatever x is, y is, because they're equal to each other. Okay, so 0, 0, 1, 1, 2, 2, 3, 3, and so forth. Okay, so if we graph this equation, it's going to just get us a line that passes through the origin here and extends on down, -1 to 1, -2 to 2, and so forth. So it goes right through the origin like at a 45-degree angle, okay? We want to be able to identify key features of this function. So what's my domain? What's my range? So if you recall, my domain is my graph going left to right. Okay, so I go from the left, how far does it go? If I go to the right, how far does it go? When in a linear function case, the arrow, no matter what I do, it's going to keep going down and down and down. So my x values are going to keep going over and over and over. Same thing to the right. So we call this infinity to infinity, and you need to be able to write, proper notation. The open brackets means it does not include the number, and so infinity is never included because it's not really a number. It's just a, ongoing, values and so forth. So we go from infinity to infinity. Range is the same thing. It's going to keep going down with my y values all the way up to my y values, and so my range is also, this would be negative infinity. I'm sorry, negative infinity to infinity. Okay. My y-intercept is at 0, 0. And that's mostly what I'm going to be concerned with for today. I'm not going to be concerned with our x-intercepts, okay? And that's pretty much our key features of a linear function, okay? So we start from there. So knowing all these key points, the fact that it goes over 1, up 1, the y coordinates equal to the x coordinate, and then we start shifting from there, okay? So that's our first one. Our second one is an absolute value function. So notice that this is still kind of y equals x. The only difference is I'm going to go from 0 to 0, 0, 0, 1, 1, 2, 2, 3, 3. If I make a table of values here, right? If I put 2 in there, it's going to be 2. 1 is going to be 1. 0 is going to be 0. But if I put -1 in here, instead of being -1 like the linear function was, it's going to become a +1 because of the absolute value. So once it comes down here to the origin, it's going to kind of bounce back up here into the positive quadrant for my y values. So it's going to be +1. -2 will be +2. So -2 will bounce up here into the +2. Okay. So what we end up with here is a graph that looks like a V. Okay. So knowing the general shape of this graph, it's a V function, making sure you understand that and understand this ratio of, x is 1, goes 1, over 2, up 2, and so forth, over 1, up 1, over 2, up 2. It's going to be really important when we start dealing with stretches to understand this vertical, if I go over 2, up 2, that kind of that y value, okay? My domain, if I'm looking at my graph, it's going to go left to right forever because the arrows go forever. So I'm going to go from -infinity to infinity. My range does not go down forever, right? It stops right here, okay? So my range on the lower part is going to be at 0, and I'm going to put a boxy box there because it includes the number 0, okay? And then it's going to go on up to infinity. And of course, you put an open bracket there because it does not include the number infinity because there's no such thing. Okay. My intercept again, my y-intercept is all I'm concerned with is at 0, 0. Okay. And we're good to go. Other is it's a shape of a V. It's a V shape. Right. And so make sure you kind of understand that whenever anybody says absolute value graph, it should look like a V and nothing else. Okay. Okay, onto our quadratic function. This is a parabola. Okay, this is called a parabola. Parabola. Okay, how I graph that, let's go ahead and do a table of values here and see what happens. I have x and y. Okay, if I plug in -2 for x, -2 squared is 4, right? -1 squared is 1. So -1 squared is 1. 0 squared is just 0. So right there. Okay. 1 squared is 1 and 2 squared is 4. So 1 squared is 1. 2 squared is 4. So you'll notice this. Let's go ahead and plug in 3, right? 3 squared is 9. So it's kind of this relation of all my square values. Negative 3 squared is also, oops, I put that at 8. Sorry, guys. Should be up here at 9. Negative 3 squared is also 9. Okay? So what you have here, it's not a V shape. It ends up being kind of a, not kind of, it is a U shape. Okay? So I missed my point. That's okay. Okay, so this is a U shape. So anytime you see the squared function there, anytime you see a squared in your equation, you know it should be a U shape. Okay, it's a parabola, right? The leading coefficient here determines if it opens up or opens down. Okay, so we call that A. If it's positive, it opens up. If it's negative, it opens down. And it's pretty obvious when you graph it because you'll get the values out there negative. Okay, my domain left and right is still all real numbers, so it goes from negative infinity to infinity. Whoops, I forgot my negative again. My range again starts at 0 and goes on up to infinity. Okay, so it starts at 0, going up, 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 all the way to infinity. My graph goes up all the way to infinity. My intercept again, my y-intercept is at 0, 0. Okay. Some other key functions we have is we actually have a axis of symmetry that kind of divides my parabola in half. Okay, and this axis of symmetry is, you know, x equals whatever my x coordinate is. So since this is 0, it's going to be 0. We're not going to get too technical here, but just understand that it's symmetrical. Okay, and so this graph corresponds to this point, and this point corresponds to that point. And that's really all you kind of need to know for parabolas at this point until next year. Okay. Okay, let's look at the square root function. So the square root function, again, let's just get a table of values going because it's kind of tell us what it's going to do. And we can't take a square root of any negative numbers, so we're not going to have any negative values of x, right? Because that'll be undefined. So we're going to start with 0. So the square root of 0 is 0. Square root of, and I'm going to take an easy number to get the square root of. So square root of 1 is 1. I'm not going to do 2 or 3 because you can't really take the square root of that. So I'm going to go square root of 4 is 2. So it's going to be 0, 1, 1, 4, 2. If I did 9, that's the next square, easy square number, right? Square root of 9 is 3. So 9, 3. So those are my key points of a square root function. This is what it looks like. It kind of starts at 0 and kind of branches up. Okay. So keeping mind of all these key points here. So when we go to graph the transformations, you know what these key points are. It's my parent function is always going to be from 0, my point here, over 1 up 1, over 4 up 2 because it's a square root, over 9 up 3 because it's a square root. Okay. My domain this time starts at 0. My graph doesn't go past 0 on the x-axis. It goes to infinity. So it's going to go from 0 on the left-hand side to infinity on the right-hand side. Okay. My range on the bottom is going to go from 0 up to infinity. Okay. My intercepts, again, my y-intercept is 0, 0. Okay. And that's pretty much it. Okay. And so those are all of our parent functions. And so understanding our parent functions, like here, you know, what are these key points on here? So when we do our transformations, where do they move? They're always from our vertex or from our endpoint. It's important to know where these points lie in relation to those so we can graph them easily. Okay, so we're going to look at some transformations now. So this kind of is a little bit confusing, so don't get too caught up in that. But basically, if we have any kind of number out in front, if it's negative, it's going to flip it over the x-axis. I don't know what that is here. It's going to flip it over the x-axis. If A is positive, it's going to stretch it or make the graph really tall. If it's a fraction, then it's going to make it kind of make it closer to the x-axis, going to kind of make it wide. Okay. We don't deal with these a whole lot, so I'm not going to worry about that. Okay. But if you have in parentheses x minus some number, that some number is going to be a shift. Okay. So if it says x minus a number, it's going to be a shift to the right. Okay, so pay attention to that. If it's x minus, it's a shift to the positive, so it's kind of opposite. If it's x plus, it's going to be a shift to the left. So it's kind of opposite of what the sign is. For K out here, it's exactly what it is. So if it's a positive K, it's going to shift up. So positive. If it's negative K, it's going to shift down, negative. Okay. And so here we have a stretch of 2. Stretch of 2. And it's going to shift down 5. Okay. Actually, I'm going to go ahead and do this. Let me do this here. So we have, right, we have a stretch of 2. We'll talk about what that means in a minute. And then we have a shift vertically. Oh, it didn't do my, gosh darn it, didn't do my color, my proper color. We have a shift up 5. Okay. We have a stretch here, or actually it's a compression. So it's actually going to be a compression of 1/3. Okay. And this is going to shift it up. I got to go back, guys. This is not up. This is down. That's too late. Okay. Down 5. Sorry. This is up 3. Okay. This one we have kind of a combination. Right? We have a stretch of 2. Okay. Then here we have a shift which way? It says -5, so it's instead of minus going to the left, it's going to actually go positive to the right 5. It's going to shift right 5. Okay. And then this guy tells it it's going to shift up 3. Okay. This one right here, this says it's going to shift, instead of positive 3, it's going to go to the left 3. Okay. So it's kind of opposite. It's counterintuitive. And then for my K here, it's going to shift down 2. Okay. So that's how those work. Okay. So now let's go ahead and practice it. So now we have just a linear function, because all we have is x to the first power. That tells us it's a linear function. Okay. We're going to shift down 5. And that's how you tell our y-intercept. Yeah, kind of sounds familiar, right? Y-intercept. We have a stretch of 2. So instead of going up 1 over 1, we're going to go up 2 over 1, right? Up 2 over 1. That's our slope, which is also a stretch. So it makes our graph a little bit steeper than it normally would. Okay. Our domain, notice, stays the same. It's going to go from, gosh, I keep forgetting my negative infinity to infinity. And my range is also going to go from negative infinity to infinity. My x-intercept, all I care about again is my y-intercept. I'm not going to worry about my x-intercept. Okay. This is at 0, -5. Okay. Can't write very good. And that's about it. All right. Okay. Moving on. Now this is an absolute value function. The first thing I'm going to see are these little vertical lines here, and that tells me it's a shape of a V. So it's going to be a V shape, right? Okay. So what I like to do sometimes, I'm going to take my parent function here, and I'm just going to kind of dash it in here so I get like a general shape of what my parent function is. Okay. My parent function right here. Then I'm going to graph my shift. So this tells me it's going to shift up 3. Okay. So 1, 2, 3. There's my new vertex. Now from my vertex, I normally would have this point right here, right? That would be my normal point. But we have this compression of 1/2, which means instead of going up 1, this vertical, we're going to take that 1 and cut it in half. Multiply it by 1/2, which gives me this point right here. Okay. So this vertex kind of becomes like, oh my goodness. This vertex kind of becomes like our new origin, right? We go over 1, up 1, but instead of up 1, we're going 1/2. Okay. We go over 2 usually and go up 2. But we're going to cut that 2 in half, which is going to give us a 1. Okay. And we're going to do the same thing on the other side. This one also has some symmetry to it. If I go over 3 and up 3, well, we're going to cut that in half to 1.5. Okay. So that's what that compression does. It kind of squishes it down towards the x-axis and makes it wider. Okay. That's what the compression does. So we shifted up 3 and we compressed it by 1/2. My domain is still going to be negative infinity to infinity. My range is going to now, instead of from 0 up, it's going to shift up to 3. So we're going to start at 3 on the bottom, and it's going to go up to infinity. Okay. My intercept, my y-intercept is 0, 3. And usually you label it on just on your graph or you can just write it out. That's fine too. Okay, and that is how you graph that transformation. Let's go on to the next one here. Now this is going to be a parabola because it has a squared function right here, so I immediately know it's going to be in the shape of a U. Okay, and so again, we can take our parent function if we want to, and kind of up to 1, 2, 3, 4. So those are kind of our parent function right there that we're going to be shifting around and moving around and stretching. Okay, so we're going to shift to the right 5, positive 5, and then up 3 from our vertex. Okay, so we're going to go 1, 2, 3, 4, 5, and 1, 2, 3. That's our new vertex. So it's kind of like our new origin. Okay, and if you remember, our parent function would go, our 1 squared is 1, 2 squared is 4, right? Well, 1 squared is 1, but this time we're going to multiply it by 2 because that's a stretch. So 1 squared is 1. So instead of going up 1, we're going to go up 1 times 2. So we're going to go up 2. And then, of course, it's the same on the other side. Remember that that reflection, right? Axis of symmetry, right? So remember when we went over 2 from our origin and we squared it, 2 squared is 4. 1, 2, 3, 4. But we have that stretch of 2, so we're going to actually double 4 and go up another 4, go up 8 right here. Okay? And the same on the other side. And so now what that stretch does, the 2, is it makes it a little bit steeper graph. It stretches it. Okay, that's why it's called a stretch. My domain stays the same. I'm going to go from negative infinity to infinity. My range is going to go, it's shifted up now, right? And so it's going to be up at 3. So we're going to also go from 3, it includes 3. So we're going to put the boxy there, up to infinity. Okay. My intercept, I'm not really sure what it is. It's going to intercept the y-axis way up there somewhere. We could plug in 0 here to find out what that is. So we go y equals 2 times x minus, 0 minus 5 squared minus 3. So y equals 2 times negative 5 squared minus 3. This equals 2 times 25 minus 3, which is 50 minus 3. So my y equals 47. So even though I can't graph it, I can find it, right? So my y-intercept is at 0, 47. So you just got to plug in 0 for x into your function and find out what your y variable is. Okay? Okay, we got one more. This is the square root function. Remember our square root function, our parent function for that guy starts here at the origin. We go over 1 up 1 and we go over to 4. 1, 2, 3, 4. This is very similar to the square root function, but it's kind of sideways. Okay, so here's my my parent function here. Okay, and then I'm going to shift left this time, left 3 and down 2. Okay, so I take this endpoint here, 1, 2, 3, down 2. There's my new origin. I don't have any stretches, so all I need to do is redo these points. So it's over 1 up 1, over 1, 2, 3, 4, up 2, and then I can just graph that guy there. Okay, my domain shifts, right? It shifts over 1, 2, 3. So I go from 3 to infinity. My range goes down 2, so that's going to go from 2 up to infinity. Okay, again, my intercept, this is going to be a little bit trickier to find, but we've got y equals square root of 0 plus 3 minus 2, square root of 3 minus 2, and you'll have to probably put this in a calculator. That's going to be 1 point something, so it's going to be a little negative number. So that one might be a little bit trickier to find. I don't have my calculator up right now, or I would find that for you. Okay, so that is how to graph your parent functions and all of its transformations. So make sure you kind of learn those parent functions really, really well. It's going to be important next year in Algebra 2 to understand those parent functions. If you know those, you're going to be way ahead of the game. Okay, you have a worksheet in Google Classroom, and then I will see you guys tomorrow. Take care. Bye-bye.